Today we have to expand our thinking off of these quadratics that we've been doing into something a little bit longer, like a polynomial. Okay? And so eventually we want to be able to graph these polynomials, factor these polynomials. Before any of that can happen, we've got to get good at dividing polynomials. Okay? Now, there's a couple ways we can divide it. Okay, the first way is long division. So I'm just going to make up, I'm going to call it review of long division. I'm going to take just a number like, let me start with 3 right here, 3207. 3,207, and divide it by 5. So just as a review here, I see how many times 5 goes into 32. Well, it goes into it 6 times. So there's 6 up here. I multiply, come down, and I get a 2. Okay, I drop the 0. 5 goes into 20 exactly 4 times. So I don't get anything down there. And then 5 goes into 7 1 time. It's kind of a review for you. And then what we do with this remainder is we add on another term. We would say that the quotient is 641 and 2/5. If you check that in the calculator, it should work. I want to expand that thinking into dividing polynomials. So I'm going to take this x cubed. And one thing I have to notice on dividing polynomials is that I'm missing a term in here. I'm missing that 0x squared. So I'm going to put it in. It's just going to be holding on to that place. And I'm going to divide it by x minus 4. And what happens is a lot of my steps are the same on this. I got some x's floating around, but really all I need to do is just look at my leading coefficients. And I'm going to be using the same rules. If I look over here, what I did first on this 3,207 divided by 5 problem, I saw, well, 5 goes into 32 6 times. Or I can think 5 times what gives me something that goes into 32, and it was 6. In this case, over here, I'm thinking this x right here times what gives me x squared, or how many times does x go into x cubed? And the answer is x squared. So next, what I do with this 6 right here is I multiplied it down and got 30. So I take x squared, I'm going to multiply it by this binomial over here. So I get x cubed minus 4x squared. Next, I subtract it. I ended up with just 2. So I want to subtract here. Now, these are going to cancel. Anything subtracted from itself is 0. I'm about to sneeze. Hold on. Oh, it went away. Never mind. So I get, on the second part, I get 0 minus a negative 4. A lot of people are going to put a negative 4x squared there, but I'm subtracting off a negative 4, so it's positive 4x squared. I drop the 0 on the left side, so I drop the negative 7x over here. And then I like what one of my students said this morning. He said, well, just repeat. Just keep doing the same thing over and over. Exactly. I saw how many times 5 went into this 20 right here. And so I want to think, what times x? Again, just working with this leading coefficient right here, what times x is 4x squared? And it's 4x. I multiply it, come down, just as I did on the previous problem. Minus 16x is, let's see, again, I'm subtracting that. So that's going to bring that over to a positive 9. And then finally, what times x gives me 9x? That has to be 9. 9 times x gives me 9x. 9 times negative 4 is negative 36. So I end up with my remainder on this one after I subtract to be 30. And what I want to do with that is I'm just going to add another term. I put my remainder over my divisor. Okay. I can definitely check my work on this. If I was to multiply my answer right here by, let's see, my answer right here is called a quotient, by the way. If I was to multiply it by this x minus 4, or my divisor, I should get what's inside parentheses, or what's inside my square root, my division bar right there, and that is my dividend. And that would work. Okay, and that's the whole idea behind this division algorithm. Now, I'm not going to erase all this because I still need part of it. But if you kind of read through that, and that's the idea, is if I take my divisor and multiply it with my quotient plus whatever my remainder is, it gives me back to that original function, my dividend that I started with. Okay. And in case you need a step-by-step, there's going to be a couple of them in the homework that I assigned. And so I've included a step-by-step write-out of everything I did on that first example. But if you look at this, there's a lot of shortcuts on this. Or not a lot of shortcuts, a lot of repetition that's going to lead to shortcuts. And the math nerds came up with a really good shortcut for this. It's called synthetic division. And so what I do is I kind of ignore all my x's that I have over here, and I just use the numbers. So the 1, the 0, the -7, and the -6 I bring it over. And what I do is I take the opposite of what I have here. Eventually this is going to be in parentheses. So I'm going to change this -4 to a +4 and put it outside. And what I'm going to do is I'm going to turn this long division on its head. So I'm going to flip my radical around. Now the first step whenever I work this is I just bring this 1 down right here. And again, this is going to be a shortcut. I'm not going to show you step by step what the shortcut is from long division to the synthetic division, but let's work it out how we're supposed to, and then we'll look at some of the similarities. Okay? So from here, what I want to do is I want to take this 4, I'm going to multiply it to that 1 right there. And I get 4. After I multiply it, I'm just going to add up these columns vertically. And just like my student said this morning, I repeat. So now I'm going to do the 4 times 4, and then I add my columns. I do the 4 times the 9, and then I add my columns. Those numbers on bottom should look familiar to you. Those are just the numbers that we had up here in my quotient from the long division problem. And look at this 1, 4, 16, 36 I had in here. Look at some of these numbers in here. 1, 4, 16. I had a 36 right here. You know, there's a 9. I'm pretty much just taking out the x's in this long division and all the repetition and shrinking this problem up. So my final answer will be, now this back number right here will always be my remainder. So I always throw my remainder over my divisor. And I've got my constant term in front of that. I have my x term in front of that. And I have my x squared term in front of my x term. So this is my final answer. Much quicker than long division, not nearly as much writing going on. Let's try that again. Okay. Actually, I want to introduce it. This is actually, like I said, called synthetic division. It's a shortcut that's used when the divisor of the binomial is in this form. It has to be in this form in order to use this shortcut. Okay, x minus whatever my k is. So x minus my constant. So let's use this to try it again on this problem. So I start with just my coefficients on my dividend. The 2, the -3, the 4, and the 5. Okay, now I've got to do the opposite of this. I know it's supposed to be x minus my k. Whatever my k is, it comes down. So in this case, it's x minus -2. So you can always just think, I'm just going to take the opposite of whatever I'm dividing by. So from here, I drop down to 2, and I just multiply and add, multiply and add, multiply and add. Just repeat it over and over again. Multiply, and then I add. I multiply, -2 and -7, and then I add. I multiply, and then I add. And that would be, it's not my answer. This back guy is my remainder. So I've got to rewrite this. Those are my new coefficients that go in front of my polynomial. I can just throw my remainder at the end of it. Okay. Okay, we'll go ahead and pause the video, let you try this one, or I think some of you are just letting it play, and then you can pause it and see if my work makes sense, whichever way you're working it. Yeah, I got 2x cubed minus x squared minus 25x minus 12. Now, my remainder on this one is 0, so I can just leave it off. And also notice that my degree on my polynomial, my highest exponent, is 3 on this, which is 1 less than when I started with. So it should always go down by 1 on this synthetic division. All right, a little bit of a curveball on this one. Okay. My divisor is not in that form x minus k. So I'm going to force it into that form by dividing both sides by 2, and I get x minus. Unfortunately, I get x minus a fraction on this. Okay. So I will be working with a fraction on the outside of my box right here. Now, I can't just divide my divisor by 2. If I divide the divisor by 2, I need to come through and divide my dividend by 2 as well. So there's good news and bad news with that. Some of my numbers get smaller. I guess they all get smaller. They all get closer to 0. But some of them turn into fractions. In the end, it's all going to be good news. I should get, for the most part, I should get all my answers to come out to be nice integers when I run that. That still follows the same thing. I just drop this one down. You just might have to take a second to add that up. I got negative 9 halves plus 3 halves. That gives me negative 6 halves. Well, negative 6 halves is just negative 3. And multiply again, I get negative 9 halves. When I subtract those, or I guess I'm adding 21 plus a negative 9 is 12 halves. Plus just 6. So even though I had these fractions in here, I'm still getting everything to come out to be nice for me. And so my final answer would be x cubed minus, 3x squared plus 6x minus 4. It's hard to do a word problem with this because we're trying to build up to something else. So I found this one that's like one that we're going to do in the homework, where it's giving us some geometry. It's saying that the area is given by this polynomial right here, while the width of the rectangle is given by x plus 6. Find an expression for the length. Well, how do we get length when we're given area and width? Well, for a rectangle, I know that area is equal to the length times width. So if I'm looking for the length, I solve this for L. I know that A over W equals L. A over W. It makes me think of A and W root here. That would be good right now. Anyway, so I'm simply taking my area polynomial and dividing it by the width. In other words, I'm just taking this 3, 14, negative 23, and 6. And then, again, I have to change the sign on this, putting this negative 6 out here. Pause the video, you can work it, and then we'll come back. Once again, I get my remainder to be 0 right here. That's a very special case whenever that happens. We love when that happens starting tomorrow when we start doing remainder theorem and factor theorem. But my length for tonight is going to be this polynomial right here. Got 12 problems for you. Make sure you read your directions on this. Number 3 and 9 want you to do long division. In case you see a long division on your quiz, I want you to have that to reference to. Other than that, we're doing synthetic division on the rest of it.